This is the two-dimensional truss problem that we are going to solve in Ansys APDL. There are 7 key points and 11 elements. The given data is E is equal to 200 gigapascals and the cross-sectional area is equal to 3250 millimeters square. This means that all the elements are of same material and they have same cross-sectional area. These are the key points of the truss, and we will use these coordinates to create key points in Ansys APDL later. And in general, a finite element solution can be broken into 3 stages, which are pre-processing, solution, and post-processing. In pre-processing, we will define the problem by defining key points, lines, areas, volumes. So we define the element type and material, also the geometric properties, and then we also do the maze. And in solution, we assign loads, constraints, and solve the problem. We can assign loads and constraints in the pre-processing step itself, and in the post-processing step, we list the nodal displacements and then calculate the element force and moments, create deflection plots, and also plot the stress contour diagrams. Let's go to Ansys Workbench. In Ansys Workbench, double-click Mechanical APDL and give it a name. I'm going to give it the name 2D Truss. Now right-click Analysis. It will take a bit of time. Then go to Edit in Mechanical APDL. Edit in Mechanical APDL. This will open 2 windows. One is command window and the other is the window with user interface. Let's start right away. Then first of all, go to File, and we don't need to clear and start new because we have just started APDL. Change the job name. Give it. You can give it any name you want. I'll give it 2D Truss. This name will appear here. Now again, go here and change the title. 2D Truss. You can give any name again. It can be different than the job name. And this title will appear here. Whenever we save any image, this title will appear. So let's go to preferences, and then as we are solving a structural problem, let's select structure. Okay, then let's go to pre-processing step, which is the first step of solving the problem. And then select element type. We define the element type here: add, edit, and delete. Add. Then select this link, which is the simplest element. Select 3D 180. Okay, and link 180 is selected. Close. Now for link 180, we cannot put real constants from here. For the newer versions of Ansys, but in older versions of Ansys, we could have input the real constants from here only. So to input the real constants, which is the area for us, we go to command line and type R. 1 is the reference number of link 180 section we created, and give the area 3250. This is in millimeters square. In Ansys APDL there are no units, so we ourselves need to be consistent with units. Click enter. So when we go to add, edit, delete now, we can see there is one set of real constant defined already. So we are good to go. Now we can go to material properties to define the material. Go to material models. We don't need to define a new material now. We can go to structural, linear, elastic, and isotropic. As we are given the value of E, that is 200 GPa, but to be consistent with the units, we need to input the value of E in Newton per millimeter square. So give it 200,000, and the value of Poisson's ratio, let it be 0.33 for steel. Okay, and close it. After applying material, let us input the key points by going to modeling, create key points, and in active CS means current screen. We will input all the key points and the coordinates that I showed you before. First coordinates is 0, comma 0, apply. The second coordinate is 1800, comma 3118, apply. So we can see one coordinate 1 and coordinate 2. Similarly, third coordinate is 3600 and 0, apply. 4, 5400 and 3118, apply. 5, 7200 and 0, apply. 6, 9000 and 3118, apply. And the final key point is 7, 10,800 and the y coordinate 80. So hit apply. If you hit apply, don't click OK, because it will create two points with key point number 7. So if you already hit apply, click cancel, or if you have not click apply, you can click OK. So I should click and cancel. Now after we created key points, we need to create lines. So go to lines and create lines and create inactive coordinate system and go and pick number 1. And when you go towards 2, it will automatically show line, and when you do left click, it will create a permanent line. In the same way, create all the lines like this. So this is all the lines. Okay, so we are done with modeling. We have made the geometry. We've given the cross-sectional area, material type, element type. So we can go to meshing. So before meshing, we need to tell Ansys APDL the sizing of the meshing. We'll do it by going to meshing of preprocessor and size control, manual size, and lines, all lines. So we are giving all lines the same size. And to make it simple, we are going to give only one division per line. So this will be one mesh, one line will be one mesh, and click OK. So there are 11 mesh. So now we are good to go. We can create mesh. So go to mesh and create lines and go here and do pick all. So this is what should be appearing in your window. After this, go to plot numbering. Plot controls, numbering, and select key point number and node number, and do element numbers, so that you can see the element numbers and key point numbers. So after this, we can apply the load from the preprocessor step, as well as we can apply the load from solution step. So let's go to solution and go to define loads and apply structural. Let us first apply the constraints, displacement constraints, and since we are applying the constraints in key points, let's select on key points. We have two constraints. The constraint at key point 1 is a fixed constraint, and the constraint at key point 7 is a roller constraint. So select key point 1, click apply. So click all DOF and displacement value is 0, apply. And again click 7 and OK. And here only UI has value 0. Okay, so we have defined the displacement constraints. Now we need to apply the force. So go to force movement on key points, and the first point is 1. Click apply. We have Fy, change it to Fy, and the value of force at key point 1 is 280 kilonewton downwards, so we are going to apply 280 kilonewton minus, and since we have to apply it in Newton, we are going to do 280,000. Apply. Similarly, point 3, apply, it's 210. Apply. And point 5, apply, the load is 280 kilonewton. Apply. And finally at the point 7, you can click OK now, and the load is 360 kilonewton downwards. Okay, so now we have applied, we have defined all the loads now. Then after applying the loads, we can go to solve. The solving is also under the solution. Go to solve and current ls, begin solution of current load step. Okay, then the solution is done. Because it's a simple problem, the solution is done in very short time. Click close this. Now we can go to the general processing. We have completed the solution stage. Now we are on the third stage. Go to general processing, and first of all we can see, let's go to list results, and nodal solution, and BOF solution, displacement vector sum. Okay, to see the displacement of each node we go to nodal solution. Okay, so we get this result for node 1. These are the displacements, and this is the sum of displacements. So we can get this result. We can save this result as well. Similarly, we can go to plot results and go to contour plot of nodal solution and plot any variable we want. Let's go to the deformed shape, and so deformed and undeformed shape both. Apply, cancel. So this is the undeformed shape, and this is the deformed shape that we obtained after applying the load. We can also animate the deformation by going to plot controls and animate and deformed shape. Okay, so we can see the deformation like this. Let's stop this. Now to save this information, we can go to plot controls and capture image and file, save as bitmap file in any location you want. Similarly, one more thing we can do, we can see a lot of results in the post processing. Let's go to one more thing, that is element table, and define the table. 8. Go to sequence by sequence num and select ls and click 1. This is for one reference element, and ls give means the axial stress. Click OK and click close, and we have defined that table, and we can plot the element table here, ls1, without averaging. Okay, so this is the stress value, stress in the truss. So we can do post processing like that, and we can save this image by going to plot controls, capture image, file, save as. You can save it as str stress, and it will save as I have saved auxiliary trace, deformed shape, we can save with any name. Save. So this is it with this problem. We have gone through pre-processing, solution, and post-processing, and this is a very simple problem, and we will continue with advanced problems later. Thank you.